compared to urban areas. I mean, do you have this kind of information in your data?
Yeah, so we have municipality level data,
yeah,
not within. And clearly, some municipalities are more rural and some more urban. We could look at that division, but we haven't. Because our focus is very much on using all the municipality variation in entry to lockdown and exit from lockdown. But sure, we can try to classify as rural urban.
Sorry, just one more question, if this is okay.
Yeah.
Also, you know, I kind of wonder whether, you know, these calls to police or to hotlines were made by the victims themselves, or the neighbors or the friends. I mean, you know, in one paper I read yesterday, which was about domestic violence during lockdowns, was saying, in fact, you know, majority of calls, I think that was about, it wasn't about Chile, but it was about some other countries. It was saying that majority of calls to hotlines were made by the neighbors. I mean, do you have this kind of information in the data as well?
You know, there's a UK paper making that distinction and showing that the increase in calls was driven by third-party reporting in Britain. For Chile, we don't have that information.
I see. Are there any other questions from the floor? All right, thank you very much, Sonia. It was really great to see you. I'm really happy. Thank you so much for your contribution. And the next speaker is Dr. Matt Dixon from, we were all at the same university, from, you know, University of Bristol. But welcome, Matt. How are you? Hello.
Hello. Hello,
how are you?
Yes, how are you?
It's great to see you, Matt.
It's very nice to see you too.
Thank you. It's a great pleasure for us to welcome you as well. If this is okay, I would like to make, you know, a brief introduction, if this is okay with you.
Of course.
So as I said, our next speaker is Dr. Matt Dixon from University of Bath, UK, United Kingdom. He's a reader in public policy at the Institute for Policy Research, where he also leads the program of research on widening participation in higher education. His current projects examine the earnings returns to undergraduate and postgraduate degrees, the role of further education and progression to higher education, and the impact of early health on later education and labour market outcomes. He has been at the University of Bath since 2012. So prior to joining Bath, he held positions at University College Dublin and the University of Bristol. His research primarily uses microeconometric techniques applied to large-scale survey and administrative data sets to address research questions related to the economics of education. He's also a research fellow at the ICDAH, which is Institute of Labour Economics. So his presentation today is about the causal effects of education, adult health, mortality and income, evidence from the Mendelian randomization and the raising of the school living age. Matt, it's a great honor for me to welcome you. The floor is yours.
Okay, thank you very much, and thank you. Yeah, I mean, it's great to be here. Let me just try and share my screen here.
Sure.
That should be right. Okay, there we go. Okay, well, yeah, thank you. This is, I wish I was there in person.
Well, we wish the same thing.
Yeah, it would be
maybe in the next conference.
Next time, yeah, that would be.
Yeah, we really hope so. Yeah.
Definitely. But I'm delighted to be able to be here and present this work today. So this is, as Merv said, this is looking at the causal effect of education on adult health, mortality and income, and using evidence from two different instrumental variable strategies. And this is joint work with Neil Davis and George Davies-Smith, who are at University of Bristol and who are both epidemiologists, and Frank Windermeier and Gerard Vandenberg. Frank is now at Oxford and Gerard is at Groningen. Okay, so I'll crack straight on. Oh, is that going to let me do that? There we go. So by way of motivation, we know there's a large literature looking at the relationship between education and health. And on average, you find that people with more education are healthier, are happier, higher intelligence, are richer, they're longer lived than people with less education. And as ever, there are several potential stories as to why this is. So one of them is the kind of causal story that education directly causes these outcomes. And that could be by increasing income. So there's a whole load of papers, obviously, in every country in the world about how education causally affects income, and this can then affect your health outcomes. But alternatively, it could be that education improves health knowledge and affects people's behaviors, and also their kind of health efficiency, so how they use information and translate that into health outcomes. And so that could be, you know, the causal effect coming through there. Or it could be that education directly changes people's time and risk preferences, and this then has implications for their health outcomes. So they're the kind of causal story, but the alternative, as ever, is that actually this relationship, this correlation that we observe, the education health gradient, or the education gradient in health outcomes, is due to some socioeconomic confounding or genetic or genomic confounding. So factors that determine educational attainment are also impacting their health accumulation. Okay, so it's not a causal relationship at all. And obviously, as with all these kind of interesting economic questions that we look at, you know, the answer to whether it's causal or the extent to which it's causal affects policy in a big way. So it's really important to establish that. And I guess the third potential issue is reverse causation. It could be that health actually affects education, and this could be, you know, if you are in poor health as a child, that might affect your educational outcomes, and then, you know, as health is correlated over time, it could be then that, you know, you've got low education and you've got poor health, and so it's health driving the education. So as ever, in order to establish the causal effect, we need some plausibly exogenous variation in education. Ideally, you know, you would have some kind of randomized experiment, but this is very difficult to do in education. So we would generally be relying on kind of natural experiments to create instrumental variables. So we've got that question of the causal effect, but also there's another kind of sub-question, which is whether the impact of education on health is the same across the education distribution, or does it depend on the education margin? So is it the same effect if you go from 10 to 11 years of schooling, or as if you go from, I don't know, 15 to 16, something like that? So the question is, you know, is it a local average treatment effect, or is there an average treatment effect? And to address both of these questions, we're going to look at two plausibly exogenous sources of variation in education that work on different education margins. So the classic in this literature is the raising of the school leaving age, so using changes in compulsory schooling laws to create instruments. And in the UK, this has happened a couple of times in the last century, the most recent being in 1972, when the minimum school leaving age was raised from 15 to 16. So this affected people born from September the 1st, 1957 onwards. So this is a tried and tested solid method to create instruments for education. And then the second method, which is less known in economics, I'd say, but is increasingly becoming known, is the use of genetic variants that are associated with education. This is known as Mendelian randomization, and I will spend a bit of time going into that in a second. Okay, I'm not going to spend any time, well, barely any time on the literature. Essentially, using school leaving reforms, there's a bit of a mixed picture certainly in the UK literature. Some papers find no effect of education, causal effect of education on outcomes. Some find positive, some find negative. So it's all a bit of a mixed bag there. When it comes to MR, there's far fewer papers, and there's not really any in the UK, apart from one other one that we've done. And essentially, again, generally find positive effects, but it's small samples in a lot of cases. Okay, so I'll just run through kind of theory on the instruments in both cases. So standard 1972 Rosler, we need the instrument to be relevant. So we need to show that being affected by the policy increases your likelihood of staying in school. So we can show this, the kind of first stage regression. And then as standard, we need the instrument to be valid. So we need no effect of the reform, this law change on health outcomes other than through the effect on education. So we can't really test this, as always is the case with instruments. We can't test this, but there's lots of work in the literature that suggests that, you know, this reform is a valid instrument. Okay, there's no reason why it would affect health outcomes other than through education. And also we need the instrument to be independent, so no pre-existing differences between those affected by the reform and those not. And so I can kind of show you some balancing tests on that later on. Okay, just by way of showing the first stage here, you can see these triangles represent the proportion of a cohort leaving with 10 or fewer years, which is the old minimum. And you can see that at the vertical line, when the policy comes in 1957, this drops down to basically the triangle's down to 0. There's a bit of looks like non-compliance, but those are the quarters where the school year in England runs from September the 1st to the end of August in the following year. And people leave, when they leave at the end of school, generally in kind of May, June time. So you get a few people, these looks like non-compliance, but these are people who left school at 15. And so when that's recorded, it looks like they haven't stayed to the minimum, but actually they've left, they're 16 by the end of the school year. It's just that when they physically leave, they're only 15. Okay, so first stage works. Moving on to the second instrument using the Mendelian randomization. So what we're doing here, we're using the natural experiment that occurs at conception to test whether, you know, your education affects your later health outcomes. So a genome-wide association study in 2016 identified 74 of these SNPs, single nucleotide polymorphisms, which are associated with educational attainment. Okay, so we're going to use those to create a score for educational attainment for each individual. So at conception, each child, you know, inherits half of their genomes from the parent, each of their parents. So there's a 50-50 chance at each point where genomes differ, you've got a 50-50 chance with each parent. And these laws of genetics, which my epidemiology colleagues confidently tell me, means that, you know, these education variants are independent of other genes that are inherited. So these alleles are just the points, these are where genes differ. And so if you get genes for one trait, you don't automatically get genes for another because they're kind of independent as you inherit these things. So the great thing is that, you know, these genes are set at conception, so there can be no reverse causation of education to genes or any causation from outcomes or choices back to genes. Okay, so it works really nicely. So we're going to construct this weighted allele score for educational attainment in the UK Biobank data. So this is the sum of the number of education associated genes for each participant, weighted by the size of the coefficient reported in the genome-wide association study. So we're going to then normalize this score, and we get essentially the score represents the effects of known genetic variants that affect educational attainment. And we've checked that our kind of frequency of these alleles in our data is similar to in the GWAS study. And the UK Biobank was not part of that GWAS study, so it's kind of separate data set. And yeah, we have very high correlation between these allele frequencies. So there's nothing genetically special about the people in our data, I guess, is what that's trying to show. So again, with this instrument, same criteria. We need to be able to show that those with the higher allele score are more likely to attain more education. So I'll show you the first stage results on that. And also, you know, validity again. So we need the exclusion restriction. So we need no impact of these education alleles on health outcomes other than through the impact on education. So it's no good if these genetic variants directly affect your blood pressure or something like that. Okay, we need to be able to rule that out. And also we need to have no pre-existing differences between people with these higher scores and lower scores. So there's nothing else in the background, another factor that's causing both the instrument and the outcomes. Okay, so we can't completely prove this, but we can show some balancing tests. I'll show you in a second. Okay, so just to think about potential sources of bias in this Mendelian randomization instrument, I mean, we basically think that the Rosal instrument is pretty solid. You know, that's that's going to be okay on the validity score as well as on the relevance score. So what we would worry about is this Mendelian randomization. So there could be issues with weak instrument, but I'm going to show you we get very high F statistics. It could be a case of a failure of the exclusion restriction. So this is what the epidemiologists would call horizontal pleiotropy. This is where the instrument impacts through a channel other than education, in which case, we're going to have an invalid IV. We can test this, we can add in, we can control for certain things, and we can use some of the kind of methods that the epidemiologists use that are more robust to any potential issue where, a gene used in the education score has some effect on an outcome directly. Okay, so there is some literature that suggests some of these 74 education variants that we use might have some direct effects on some outcomes, but we can use some pleiotropy robust methods to try and show that we don't think that's driving the results. There's something called residual population stratification, which is just the fact that at different areas of a country, because of history and ancestry, you get different distributions of genes, I guess, amongst the people. But we can control for this in all our regressions. And then I guess the other big issue is the failure of the potential failure of the independence assumption, which could come from dynastic effects or sortative mating. This is basically because the parents' genes affect the instrument, which is the child's genes, and if the parents' genes affect the outcomes directly, other than through the child's gene, which affects their education, then this could create some relationships. But I'm going to try and show you, convince you that that's not what's driving all of our results. Okay, I mean, some of this is going to be going on, but we don't think it's what's driving the results. Okay, so on the second point about is it a constant effect? Well, the ROSLA is a well understood local average treatment effect. The complier group are those who are at the bottom end of the distribution who are compelled to increase their schooling from 10 years to 11 years. So by definition, it's a very local average treatment effect. Whereas the Mendelian randomization instrument actually works across the whole distribution of education ages. It doesn't just work at one particular point. So this implies that we might be able to recover something closer to an average treatment effect, but corrected for the kind of endogeneity. It's going to be intention to treat estimates because not everybody who has these education enhancing or associated genes will get more education, but they do all work in the same direction, so that the monotonicity assumption is going to be okay. I'm going to quickly go over this slide. This is really just it'd take me a while to explain exactly what's going on, but this is really just to try and illustrate that if you look at the bottom picture, this is comparing people in different quintiles of the LL score, and what we're capturing here is the effect that these compared with the first quintile, sorry, the fifth quintile, you get this kind of layered picture. It's affecting across the distribution, whereas the ROSLA picture just really affects it at one point at the bottom. But in the interest of time, I'm not going to go into that too much, but it is in the paper. Okay, so I'll quickly talk about the data. The UK Biobank had 9.2 million invitations sent out. It's not a random sample. I ended up with 315,000 usable observations, and I like this picture because it shows where the people were, one dot representing each person. You can kind of see it gets a pretty good representation of the UK there. So it's not a random sample, but the health measures show that it is representative compared to the Health Survey of England, for example, which is a random sample. Okay, so we've got various clinical measures of height and weight and things like this, some intelligence measures. There's a link to cancer and mortality registries, so there's kind of long-term follow-up, as well as self-reported measures about whether you've ever been diagnosed with certain health conditions. There's also information on health behavior, drinking, smoking, exercise. There's information on household income, so it's not individual income, but it's household income, and also the genetic information was taken from people so that we can construct the instrument. Okay, I will breeze through this. It's fairly standard methods for estimating the IV regressions. We're going to include gender, month of birth, and these principal components of genetic stratification as covariates. So this is, yeah, soaking up the kind of these common sets of variation in genetic makeup, which are reflecting these regional differences and ancestry differences. We can also include, we haven't got great controls for kind of conditions at birth, so kind of anything pre-existing on the people themselves, so that things that we'd want to control for. But we do have things like whether the mother smoked during pregnancy, birth weight, whether the child was breastfed, location and deprivation. So we can put these in to make sure that it's, you know, these aren't what's driving the results. Okay, I've already shown you the Rosler first stage, just to say that, you know, we get F-stats in the hundreds up to thousands. So we're not, you know, we're pretty sure that this is no weak instrument problem. And we get people about 23 percentage points more likely to remain in school if they're affected by the policy. Aligns with pretty much the rest of the literature on this. Similarly, for the MR, we get very high F statistics, so no worries about weak instruments. And we also, the LL score does generate a good degree of variation in education. Okay, so it's not like we're just moving, you know, 5% and having to then gross up to a whole, you know, what we're 100% would be. We've got quite a good amount of variation. Okay, so very quickly, I'm just going to try and show you the balancing test to show that there's not confounding, either genetic confounding or other socioeconomic confounding. And the way we've done this is we've basically, almost like placebo tests, we've constructed walled estimates of the impact of effectively an extra year of education instrumented with each of our instruments, and how that affects genes and other characteristics. So it's really capturing the correlation between the instrument and the outcome, but scaled into a kind of what's the effect of one extra year of education. So I'll quickly just show you through this. I'm sorry for the size of the writing on some of this, but the thing to notice really is that all of these estimates are pretty much zero, which is what we would like, because these are all measures where we've got gene scores for all of these different for different characteristics. So whether that's kind of height and body mass, autism, schizophrenia, all these sorts of things, some socioeconomic characteristics and personality characteristics, and essentially all of our instruments show basically a zero correlation. There's the odd one, but I think given the number of tests, we might expect that we'll find something that has significance, but generally there's no evidence of bias here. When it comes to socioeconomic characteristics, there are some effects where it looks like there's some relationships here, particularly for so the blue is the genetic instrument. However, these are all things we can control for in the regressions, and that's, you know, that's what we do. Okay, so when we think we don't have an issue of confounding here, I'm going to go quickly just through some of these results. Essentially, they're all pretty much zero, very similar for the genetic and the Rosler instrument. And again, you know, we think the Rosler instrument really, because it's a policy change that was, you know, exogenous to the individuals, we shouldn't really have any relationship. And we get similar, you know, results for the genetic and the Rosler, so we're quite reassured by that. For example, yeah, the education genes and birth weight has the same size correlation as between Rosler and birth weight. There are, you know, a few things where we think, okay, comparative body size and breast fat have zero correlation with the education genes, but there is some correlation between the comparative height at age 10 and the education instrumented with the genes, which does suggest that there's something, you know, there's something going on with dynamic dynastic effects or sortative mating there, but the fact that it seems to affect comparative height but not comparative body size or birth weight suggests that it might be a particular, if it is just picking up family characteristics, something very, you know, is not straightforward to work out what's going on there. And I'm going to show you some results later on with these pleiotropy robust estimation techniques, and also some sibling fixed effect estimates, which using the Mendelian randomization, and that's going to deal with, you know, if we're using sibling differences, then we're dealing with potential dynastic effects and assortative mating. And I'm going to show you that the results support our main findings. So these are things that, you know, I'm sure all economists are thinking about these issues as to why there might be problems, and I'm sure referees are thinking about these things, but I'm hopefully going to show you that it's not what's driving everything. Okay, so results here. So we've got all these outcomes down the left-hand side, the kind of morbidity outcomes, mortality, some behaviours and income, and then in a second we'll move on to these other effects. But just to show you here, so the red dots are the actual, just the OLS estimates of the effect of 1 year of schooling on these outcomes. And then the green squares are the effects of the ROSLA, or 1 additional year of education instrumented using ROSLA. And the blue triangles are the effects of 1 year of education instrumented using the genetic variation. And I guess the thing to note really here, we do find some significant effects on hypertension and diabetes, stroke, heart attack. And in many cases, you can see the green and the blue are pretty similar, at least in direction, if not exact size. But these health behaviors, we're finding causal effect of education on reducing current smoking and ever smoking, very similar effects between the two instruments. We do have, again, some similar effects on the household income results. And then if we look at this, a second set of results, so things like these indicators of healthy aging, so grip strength, arterial stiffness, we've got an effect, it seems to improve grip strength. Again, both IVs similar, same direction. BMI, there's an effect here. And intelligence is one, this cognition score, these 13 kind of puzzles that people do. Again, we seem to find similar sorts of effects, and a little bit of an effect here on television watching. Okay, so to summarize those results, we are finding these causal effects on various things: hypertension, diabetes, stroke, heart attack, mortality. Some of the health behaviors, the smoking behavior, and some small impacts on things like alcohol and TV watching. So the two main takeaways from this is that for the majority of cases, 18 out of the 25 outcomes we look at, the IV estimate suggests that there is a causal effect. It's not just a cross-sectional correlation driven by selection, but there is actually a causal effect. And in many cases, the IVs are drawing the same conclusion, really, the causal effect, so having the same direction, if not exactly the same size. But in many cases, they are pretty similar in size. If we look at the hypertension, diabetes, stroke, and heart attack, again, you can see that these are really pretty similar, the size of the coefficients for both of the instruments. And again, with the smoking, ever smoking, currently smoking, ever smoking, and on the intelligence as well, all pretty similar size. So before having any questions, just a couple of things to head off some of the questions that I'm sure people would have. So we do loads of robustness checks. So the sample I'm not going to go through all of them, but the sample in the biobank is, there's an undersampling of the less educated, so we can correct for that. We can, include controls or not include controls, and basically all these things are the same. The main thing I want to show is these pleiotropy robustness regression techniques. So there are various things that the epidemiologists do. There's inverse variance weighting, MR-EGA, weighted median, weighted mode. These are all statistical regression methods to try and deal with any potential issue of the instruments affecting the outcome directly. Okay, so being invalid instruments. And what I'll just show you is, here's the picture, and in each case, our main, each of these are the different robustness checks, and you can see that in many cases they all look very similar to what our main results were. The MR-EGA is the most robust, and in most cases this results in a confidence interval which is covering 0, but the pattern of the results is all very similar with all of the different techniques. And so we don't think it's some kind of invalidity of an instrument on that score. And the other thing to show you that I find really reassuring is these sibling fixed effect estimates using there are siblings in the data. obviously we lose a lot of observations when we use the siblings, so sample sizes get a lot smaller, and we're only using half of the kind of variation within families. But when we just use that variation, so we're comparing siblings, so all of their, their parents are the same, obviously, and they've grown up in the same households, and so any issues about dynastic effects or assortative mating are dealt with. And it really is random, because these siblings had the same set of genes that were being chosen from, and one got, they got differences in their education scores. And okay, so as you'll be able to see, the blue is where we use a sibling difference estimator, and there, the confidence intervals balloon, because they, this is much less variation being used, a much smaller sample size. But really, just to show you that actually some of the point estimates, they don't, would expect that if it was all being driven by unobserved or genetic family characteristics, this would attenuate the results to 0. But in many cases, the point estimates actually get larger, even though the confidence intervals are over 0. And again, you can see even that the smoking results get larger. And it's same for many of these other results, like BMI, for example. So we don't think it's sibling, we don't think it's the dynastic effects or assortative mating that's driving everything. So those things, dynastic effects and assortative mating, will impact results to the extent that the intergenerational transmission of education works through the behaviors of highly educated parents. If they parent in a certain way, and if they partner in a certain way, that then there's going to create pathways to the outcomes that isn't going through the child's education. But as I said, the sibling fixed effects support the main findings. Really, we need bigger samples and data where we've got 2 generations of the same family and the genetic information, or larger samples of siblings. And the pleiotropy robust results methods suggest that, again, there are robust results there. And just, I guess, thinking about policy-wise, the variation in education due to MR and ROSA end up with similar results, right? And so this suggests that the local average treatment effect results are actually quite close to the average treatment effect results. So it just supports the idea that these findings, it's always criticized the Rosler type results, that you've got a local average treatment effect, and how applicable is that to the rest of the distribution? Well, this would suggest that actually it is applicable to the rest of the distribution. So maybe we can put more weight on the compulsory school leaving age reform IV results. Okay, I've gone on for a long time, so I will leave it there and leave time for questions.
Thank you so much. That was really interesting. I mean, it was really interesting to see how similar the results were for both, the raising of the school living age and the Mendelian randomization. It was really interesting. Thank you so much. Are there any questions from the floor? We have a couple of minutes left. If there are any questions.
If no one else will, can I ask?
Yes, please. Yes, please, Sonia.
Thanks, Matt. That was really interesting. Just on this, what you're also highlighting as your main result, the similarity of the results from using the 2 instruments. Do you think it's pointing to the effects in the MR or the 8 actually being largely driven by compliers with that last year of school? In other words, if you change school, so the average may be similar to the local because the local is driving the average.
Yeah, so I guess so one thing I did skip over a fair bit with the diagram was to show that actually, the MR instrument is working, across the distribution fairly evenly. So it's not that, you're right, that's a really good point, that it could just be that, it's the where it's working is dominated by a similar point in the distribution.
But Matt, even if the instrument is pushing education up across the distribution, it could still be that the next step in the chain, which is the marginal impact of education on health, may be close to 0. Like once you've achieved whatever it was, like 18 years of education, maybe the 19th and 20th year don't add anything.
Yeah, it could be. And I mean, I think just a law of kind of diminishing returns would suggest, right, that the impacts are going to fall with educate. There's going to be a kind of that kind of concave profile that, yeah, as you say, you'd expect less of an effect. But probably, I mean, I guess it might even be that the effects would be larger even further down, that, you know, but because of the minimum we don't get to see that. But yeah, so I suppose that's true. It could be that the effects really are kind of tailing off, and the closeness is because of that weighting on the MR. Yeah, that's a good point.
I think because I know I shouldn't have said 19 years of education. I know school leaving age minus school starting age.
Yeah.
Yeah, but I think that's really important because this is a very striking general result. And also because so the fact that the late and age are similar, but also because we don't really know whether going to university affects health. And these days, that is the relevant margin. So at least in Europe and America, the ROSLA is history. Yeah,
very true. I guess there's slight, so at the moment in the UK and well, in England, sorry, I should say, and they're thinking about it in Wales, they, you know, they have increased the school leaving, well, not the school leaving age, the education participation age up to 18. So there's a margin there, but unfortunately the policy in England hasn't really been enforced in the same way that school leaving age ones have been, because otherwise there would be more relevance, you know, to looking at that sort of, you know, we'd be able to look at that 16 to 18 margin. How much does it affect people, affect their health? And it would be, you know, more relevant because it's supposed to be happening at the moment. It's supposed to be making people stay to 18, but then because it's not being enforced, the first stage is basically not very, very strong. So it's a problem. But I agree. I think the kind of post-18 education margin is the place where the interest is. So yeah, I'll have to try and think about how to get.
Yeah. Merve, can I ask? Can I follow up?
Yes, please, Sonia.
Okay. So, I mean, one way which is slightly related and crude. I mean, it's a related question, but it could help answer this first question. Is I understand that doing the sibling fixed effects estimation addresses this concern, but before you came to sibling fixed effects, I was thinking you control for stuff like breastfeeding, but can you not control for the education of the parents?
No, we don't have that, unfortunately, in the data. No, I mean, and it's all, you know, it's obviously recall from the people who are aged 40 to 60 in the data, and then it's recalling about that. Yeah, it's really unfortunate that we don't have parental education, which obviously, you know.
The reason I was asking as a related question is if you did, just in principle, then heterogeneity, firstly, you'd use parents' education as a control to test for dynasty. But if you had it, you could also do heterogeneity by it, because at least it's predetermined.
Yeah.
And true. That would indicate this. Anyway, I would say, even if you look descriptively at the question of how much university adds, if you looked at the descriptive estimates for the compliers of the ROSLA, and they looked broadly in line with the IV estimates, I don't know if they will, then you could say, given that the descriptive looks quite similar to the IV for ROSLA, maybe I can also explore what happens at higher levels of education.
Yeah, we do know that whether they have a degree or not, and the school leaving age. So there's something we could descriptively, at least, try and get into.
Okay,
thank you. That's really helpful. Thanks, Sonia.
Thank you so much. So 2 excellent presentations, 2 distinguished speakers from the UK. It was really nice to see you both. I hope we can meet in the next conference, maybe this time, you know, in Turkey, face to face.
That would be good.
That'll be good. That'll be great. Thank you so much. Now we have to I have to give the floor to Laura. Thank you so much.
Stop sharing. There you go. Sorry.
Thank
Thanks,
you.
Merv, and thanks, Sonia. Thanks,
See you
everyone.
later. Thank you. Have a lovely day. Thanks.
You too.
Bye-bye.
Thank you.
Bye.
Bye.
Bye. Bye.
Bye.
Right, so I have to give the floor to Laura. Laura, the floor is yours.
Thank you so much for your excellent moderation. Thanks a lot. So, dear Sonia and dear Mr. Matt, really, I would like to thank you for your valuable contributions.